Before we dive in, please remember that this presentation is for informational and educational purposes only. It does not constitute professional business or technology consulting advice, and you should always consult with a qualified professional for your specific needs. Imagine it's the early 2000s. You're in charge of a small but growing company called Netflix. Your entire business model is built on putting DVDs into bright red envelopes and mailing them to people. It's working. You're disrupting Blockbuster. But you have a terrifying, exhilarating vision of the future. A future with no discs, no mail trucks, no physical anything. A future where movies and TV shows stream directly into millions of homes over the internet. Now stop and think about the sheer mind-boggling complexity of that change. How do you get from here to there? How do you transform every single part of your company? Your warehouses, your inventory system, your website, your customer billing, your marketing, your entire business strategy, without the whole thing collapsing into a fiery wreck. That chasm, that terrifying gap between where a company is today and where it needs to be tomorrow, is the reason enterprise architecture exists. Let's be honest. For most people, the term enterprise architecture sounds incredibly boring. It sounds like something that happens in a windowless basement office, involving thick binders and diagrams no one understands. But that's completely wrong. It's actually one of the most high-stakes strategic disciplines in the modern world. It's the secret weapon that separates companies that thrive and dominate from those that slowly, painfully, become irrelevant. To understand why, let's use an analogy. Think of a company without enterprise architecture as a city that grew without a plan. In the beginning, it was just a small village. Someone built a house over here. Someone else built a blacksmith shop over there. It worked. But as it grew, things got messy. A factory was built right next to a school. The roads are a tangled mess, leading to constant traffic jams. The plumbing system in one neighborhood is completely incompatible with the one next door. Nothing connects properly. Getting anything done, like delivering water from one side of the city to the other, is a nightmare. It's slow, it's expensive, and things are always breaking. This is exactly what happens inside most large organizations. The marketing department buys a fancy new piece of software to manage customer relationships. The sales team buys a different one. The finance department has its own ancient, custom-built system that nobody dares touch. Data is trapped in silos. One department's definition of a customer is totally different from another's. When the CEO asks a simple question like, "Who are our most profitable customers?" it takes a team of analysts 3 weeks to stitch together data from 12 different systems, and even then, nobody fully trusts the answer. The company is trying to drive a Formula One race car on a cobblestone road full of potholes. It's spending millions on powerful new technology, but the underlying structure is a chaotic mess. This is the problem enterprise architecture solves. Enterprise architecture is the master blueprint for the entire city. It's the urban planning for the corporation. It's not just about drawing diagrams of servers and databases. It's about stepping back and asking the big questions. What kind of city are we trying to build? Are we building a dense, fast-paced financial hub like New York? Or a sprawling, innovative tech campus like Silicon Valley? Our business strategy determines the kind of city we need. Once we know that, the enterprise architect creates the plan. They define the major zones. This is the residential district, or our customer-facing applications. This is the industrial district, our back-end processing and manufacturing systems. This is the government and utilities district, our finance, HR, and core infrastructure. They design the major highways and transportation systems that connect everything, ensuring data can flow smoothly and quickly from the sales department to the supply chain, just like goods moving on a freeway. They establish the building codes, the standards and rules that say, if you're going to build something new in our city, it has to meet these requirements. It needs to have this type of electrical wiring, this type of plumbing, so it can connect to the city's grid without causing a blackout. So what does this mean for you? Why should you spend your time learning about this? Because understanding this blueprint is a superpower. By the end of this series, you won't just know the textbook definition of enterprise architecture. You will start to see the matrix. You'll be able to look at any business problem, any new technology trend like AI, any corporate reorganization, and understand the bigger picture. You'll understand the hidden connections, the dependencies, and the potential ripple effects that others miss. You'll learn the language that CIOs, CTOs, and top-level executives speak. When they talk about capability mapping, value streams, and technical debt, it will no longer be confusing jargon. It will be the language you use to articulate your own ideas with more impact and authority. Whether you're a software developer wondering why you have to use a specific technology, a project manager trying to navigate corporate bureaucracy, a business analyst trying to connect a project to a strategic goal, or just an ambitious professional who wants to understand how successful companies are actually run, this is your guide. This isn't just for technical people. That is the biggest myth out there. Enterprise architecture is the essential bridge between the business world and the technology world. It's the translator that ensures the goals of the boardroom are actually understood and implemented in the server room. To build this blueprint, architects think in 4 major layers or domains, and we're going to break all of these down in this series. First, there's business architecture. This is the why. What does the business actually do? What are our core processes for making a sale or building a product? What capabilities do we need to win in the market? This isn't about technology at all. It's about understanding the fundamental mechanics of the business itself. It's the zoning plan of our city. Second, there's data architecture. This is the lifeblood of the modern company. Where is our critical data stored? How does it flow through the organization? How do we ensure it's accurate, secure, and consistent? This is the city's utility grid, the water mains, the power lines, the communication networks. If the data is bad, every decision built on it is flawed. Third, we have application architecture. These are the software systems that the business uses to perform its functions. Your mobile app, your website, your CRM, your ERP system. This layer maps out how all these different applications fit together, or more often, how they don't fit together. These are the actual buildings in our city, the houses, the skyscrapers, the factories. And finally, there's technology architecture. This is the foundation everything else is built on. The servers, the networks, the cloud platforms, the operating systems, the concrete, the steel, the roads of our city. It's the fundamental infrastructure that supports everything above it. An enterprise architect's job is to see how all 4 of these layers connect. They understand that a decision made in one layer has a massive impact on all the others. A new business strategy to offer personalized products, business architecture, will require a new way of collecting and analyzing customer information, data architecture, which will require new software tools, application architecture, all running on a scalable cloud platform, technology architecture. Without that holistic view, you get chaos. You get multi-million-dollar projects that fail because nobody realized the new application couldn't get the data it needed from the old system. You get companies that are agile in small teams but can't change direction as a whole because their core systems are a tangled mess of spaghetti. Today, this is more critical than ever. The pace of change has never been faster. AI, cloud computing, machine learning, these aren't just buzzwords. They are tectonic shifts that are reshaping entire industries. Companies that can adapt, that have a clean, flexible, well-designed architecture, will be the ones that seize these opportunities. Companies that are stuck in their own self-made complexity, their unplanned city, will be left behind. They will be the modern-day blockbusters, wondering how Netflix managed to change so fast. They did it because they had a blueprint. They knew what kind of city they wanted to build, and they made every single decision in business, in data, in applications, and in technology to serve that one unified vision. So we have our blueprint. We understand the 4 layers that make up the plan for our entire corporate city. But a plan is useless if it just sits in a drawer. How do you actually use it? How does this blueprint go from being a set of diagrams to being the driving force that prevents a $10 million project from turning into a $10 million disaster? How does it guide the thousands of small decisions that get made every single day? That process, the way we bring the architecture to life, is where the real magic happens. It's a system. A repeatable, understandable, and most importantly, a shared system for making decisions. Think about it. A company isn't one thing. It's 1,000 different things happening all at once. The marketing team is launching a new campaign, using a brand new analytics tool. The sales team just signed a contract for a new customer relationship management system, a CRM, that promises to triple their efficiency. Meanwhile, the IT department is in the middle of a massive project to move all the company's data to the cloud. Each of these teams is smart. Each of these projects on its own makes perfect sense. But in the real world, they don't exist on their own. They exist together inside the same company. And without a shared system for making decisions, you get chaos. You get what I call the silopocalypse. Imagine the marketing team's new tool can't actually access the customer data from the sales team's new CRM. And the IT department's new cloud platform wasn't built to handle the specific security needs of either of them. Suddenly, you have three expensive, well-intentioned projects that are actively working against each other. The sales team can't sell effectively, the marketing team can't measure their results, and the IT team is stuck in the middle trying to build custom, hacky bridges between systems that were never meant to talk. This isn't a hypothetical. This happens every single day in thousands of companies, burning through millions of dollars and countless hours of frustration. It's the digital equivalent of one team building a world-class train station, another building a state-of-the-art airport, but nobody bothering to build a road connecting the two. So how do you prevent this? You need more than just the blueprint we talked about before. A blueprint shows you the final vision, the beautiful skyscraper, but it doesn't tell you how to build it. It doesn't specify the type of concrete to use, the electrical codes you have to follow, or the process for getting a permit. For that, you need a set of rules, a methodology. In the world of enterprise architecture, we call this a framework. Now I know what you're thinking. The word framework sounds boring. It sounds like corporate jargon, like something designed to create more meetings and spreadsheets. And honestly, if it's used badly, it can be. But when used correctly, a framework is one of the most powerful tools a company can have. It's not about bureaucracy, it's about clarity. Let's go back to our city analogy. The blueprint is the beautiful 3D model of our future city. The framework, that's the City Planning Commission. It's the set of zoning laws, building codes, environmental regulations, and public review processes. It's the system that ensures you can't build a noisy factory right next to an elementary school. It's the rule that says every new building must connect to the city's water and power grid in a standardized way. The framework doesn't design the individual buildings. It doesn't tell the architect what color to paint the lobby, but it provides the essential guardrails, the rules of the road, that allow hundreds of different builders to construct their own unique projects in a way that benefits the entire city, not just their own little plot of land. Enterprise architecture frameworks do the exact same thing for a business. They provide a common language and a common process so that everyone, from the CEO to the software developer, is building in a coordinated way. There are many different frameworks out there, each with its own strengths, but two of the most famous are the Zachman framework and TOGAF, which stands for the Open Group Architecture Framework. Let's start with Zachman. Don't worry about the details, just grasp the core idea. The Zachman framework is brilliantly simple. It's basically a grid, a two-dimensional matrix. It's a way of organizing and classifying all the architectural stuff in your company. Think of it like the periodic table for a business. It gives you a box for everything so nothing gets lost. The columns of the grid are based on the classic questions a journalist would ask. What, how, where, who, when, and why? What is the data? How does the business work? Where are our offices and servers? Who performs the work? When do business events happen? And most importantly, why are we doing any of this? The rows represent different perspectives, from the high-level view of the CEO down to the nitty-gritty details that a software engineer needs. The power of Zachman is that it forces you to ask questions. If you have a box in the grid that's empty, it means there's something about your own company you don't understand. It's a tool for thinking, for making sure you've covered all your bases before you start building anything. It ensures that everyone is talking about the same thing, using the same definitions. Now, if Zachman is the periodic table, a way to classify and understand the elements of your business, then TOGAF is the chemistry textbook. It's the recipe book. TOGAF provides a step-by-step process for actually creating, managing, and using an enterprise architecture. At the heart of TOGAF is something called the Architecture Development Method, or ADM. Picture it as a circle, a continuous cycle. It's a process that never truly ends, because businesses are always changing. The cycle starts with a vision. Where is the company going? What are we trying to achieve? Then it moves through a series of phases. First, you define the business architecture. How does the business need to operate to achieve that vision? What are the key processes? Next, you look at the information systems architecture, which is made up of two parts: the data and the applications. What data do we need to support those business processes? What software applications will manage that data? After that, you define the technology architecture. What hardware, what networks, what cloud platforms do we need to run those applications? Once you have that complete picture, from the high-level business vision all the way down to the physical servers, you move into planning the implementation. How do we get from where we are today to where we want to be? You create a roadmap, break it down into projects, and manage the transition. And because it's a cycle, you're constantly governing the process, monitoring the results, and feeding that information back into the next iteration of the vision. So let's go back to our silopocalypse at Innovate Corp. How would a framework like TOGAF have helped? The enterprise architect, following the ADM cycle, would have started with the company's vision. They would have sat down with the marketing, sales, and IT leaders together. They would have mapped out the business process. A customer lead comes in, sales follows up using the CRM, and marketing tracks the entire journey with their analytics tool. By mapping this out, it would have become painfully obvious that the data from the CRM must be available to the analytics tool. That's a fundamental requirement. This requirement would then flow down to the application and technology architecture phases. The decision about which CRM to buy or which analytics tool to use would no longer be made in a silo. It would be made against the backdrop of the agreed-upon architecture. The rule would be simple. Any new system must be able to integrate with our core customer data platform. Any new technology must comply with our company-wide security standards. The framework transforms the conversation. It changes from "my department needs this tool" to "the business needs this capability, and here is how we will provide it in a way that works for everyone." It's the difference between a bunch of musicians all playing their favorite song at the same time, creating a noisy mess, and an orchestra following a conductor and a single sheet of music to create a symphony. The framework is the conductor and the sheet music, all in one. It provides the structure that allows for creativity and progress without creating chaos. Now, we've talked about the blueprint, the grand vision, and we've talked about the framework, the rules of the road for making that vision a reality. But what are the actual things we're organizing? What are those fundamental layers that every single business, from a corner coffee shop to a global tech giant, is built upon? Understanding these layers is the key to seeing your own company in a whole new light. So let's strip it all back. Imagine we're not building a company, we're building a house. A very special 4-story house. This isn't just any house. It's the blueprint for literally every business on the planet. And understanding these 4 floors is the first giant leap into thinking like an enterprise architect. Now, most people, when they think about building something, they start from the ground up. The foundation first, right? That makes logical sense. But in enterprise architecture, we do the exact opposite. We start at the very top. We start in the penthouse. This top floor is the business layer. Why do we start here? Because this floor is the entire reason the house exists. This is where the people live. It's about their goals, their dreams, what they want to do in the house. Do they want to host huge parties? Do they want a quiet place to work from home? Do they want to raise a family? Before you pour a single ounce of concrete, you have to know what the purpose of the building is. In a company, this top floor represents the business strategy. What is our mission? Who are our customers? What do we want to be famous for? It's the big why. From that why, we get business capabilities. A capability is just a fancy word for an ability the business needs to have. For Amazon, a key capability is package delivery. For Netflix, it's streaming video content. For your local coffee shop, it's brewing excellent coffee. It's what the business does. And how do they do it? Through business processes. A process is the step-by-step recipe. For that coffee shop, the brewing excellent coffee capability is supported by a process. Grind beans, tamp grounds, pull shot, steam milk, combine, serve. The business layer is all about the what and the why. If you get this wrong, nothing else matters. You could build the most technologically advanced, structurally sound house in the world, but if it was designed for a family of 5 and a single artist wants to live in it as a studio, it's a failure. The architecture doesn't match the purpose. This is the #1 mistake companies make. They buy shiny new technology without first asking, what are we actually trying to do up here on the top floor? Okay, so we know what the people in the penthouse want to do. Now we can move down to the floor below. The second floor. This is the application layer. If the top floor is about what we want to do, this floor is about the tools we use to do it. Back in our house, this is the kitchen stove, the smart thermostat, the home security system, the television. These are the systems and appliances that help the residents live their lives and achieve their goals. You don't buy a pizza oven if all you want to do is make toast. You choose the right appliance for the job. In a business, this is the software. It's the workhorse. It's the customer relationship management, or CRM, system that keeps track of all your customer interactions. It's the enterprise resource planning, or ERP, system that manages your finances and supply chain. It's the custom-built app on your phone. It's Microsoft Excel. Any software that helps execute the business processes we defined on the floor above lives here. This is where you see the direct link. The business process is, process a sales order. The application that helps do that might be Salesforce or a similar CRM. The business capability is manage customer relationships, and the application portfolio, the collection of software, is what brings that capability to life. An architect looks at this floor and asks, are we using the right tools for the job? Do we have 3 different applications that all do the same thing, causing confusion and costing a fortune? Are our applications actually helping our people, or are they making their lives harder? This layer is critical because it's the bridge between the business's goals and the underlying technology. But there's a problem. These applications, these appliances in our house, they're useless on their own. A fancy oven is just a metal box without electricity. A smart thermostat is a plastic circle on the wall without a Wi-Fi signal. They need a power source. They need a lifeblood. And that brings us down to the 3rd floor. Or rather, it's not really a floor at all. It's what runs between the floors. This is the data layer. In our house, this is the plumbing, the electrical wiring, the internet cables, the Wi-Fi signals. It's the invisible network that connects everything and makes it all work. Water flows to the coffee maker. Electricity flows to the oven. Data flows to the smart TV. Without this, you just have a collection of dead appliances on the 2nd floor, and some very unhappy people on the top floor. In a business, data is this lifeblood. It's customer information, product details, sales figures, employee records. It's the actual information that flows between all of your applications. Your CRM is useless without customer data. Your inventory management system is a blank slate without product data. The data layer is where so many problems hide in plain sight. Is the data clean and accurate, like pure filtered water? Or is it messy and inconsistent, like sludge in the pipes? Do the applications share data easily, like a well-designed electrical grid? Or is it a tangled mess of extension cords, where you have to manually unplug data from one system and plug it into another? An enterprise architect is obsessed with this layer. They understand that if the data is wrong, the business is flying blind. A sales report from the CRM will be meaningless. An inventory count will be off. The decisions made up on the top floor, in the penthouse, will be based on faulty information. Getting the data architecture right is like ensuring your house has clean water and reliable power. It's absolutely non-negotiable. So we have our purpose, our tools, and the lifeblood that powers them. What's left? What holds all of this up? We finally arrive at the ground floor, the foundation. This is the technology infrastructure layer. This is the literal ground that our entire house is built on. It's the concrete slab, the steel beams, the physical structure. It has to be strong enough, stable enough, and big enough to support the weight and the activity of all the floors above it. You can't build a skyscraper on the foundation of a garden shed. In a business, this is the hardware and the networks. It's the physical servers in a data center. It's the cloud computing services from Amazon Web Services or Microsoft Azure. It's the laptops your employees use. It's the Wi-Fi routers in the office. It is the fundamental, tangible or virtual stuff that everything else runs on. Your applications, your software don't just float in the air. They run on a server. Your data doesn't live in a cloud. It lives on a hard drive in a massive air-conditioned building somewhere. The architect's job here is to ensure the foundation can handle the load. If the business on the top floor decides it wants to launch a new streaming service for millions of users, the architect needs to ask, can our servers on the ground floor handle that traffic? If they can't, the entire house comes crashing down. The website will crash, applications will fail, data will be lost, and the business goal will fail. So there it is, the 4-story house of business. The business layer at the top, the why, the purpose, the goals, the people. The application layer below it, the how, the software and tools used to achieve those goals. The data layer running through it all, the what, the information, the lifeblood that powers the applications. And the technology layer at the bottom, the where, the hardware and infrastructure that it all sits on. The magic, the absolute core of enterprise architecture, is understanding that these are not 4 separate things. They are one single interconnected system. A decision made in the penthouse, a new business strategy, creates ripples that travel all the way down to the foundation. And a crack in the foundation, an aging server, can cause chaos all the way up to the penthouse. The architect's job is to be the master builder, the one person who understands the entire house, from the boardroom to the server room, ensuring every floor is perfectly aligned and working together to create a structure that is not just standing but is built for the future. But just knowing the floors isn't enough. How do you actually draw the plans for a house this complex? How do you create a blueprint that everyone, from the CEO to the IT intern, can understand? that requires a special set of tools, a kind of universal language for business design. And those tools have a name: frameworks. Frameworks. It sounds like a stuffy corporate word, doesn't it? Something you'd see on a PowerPoint slide in a windowless conference room. But I promise you, it's one of the most powerful concepts you'll ever learn about how big companies actually work. Let's go back to our house. Not just a house anymore, but a massive, sprawling corporate headquarters. You have the blueprints from the last video. Those are your models and diagrams. But who decided what those blueprints should even look like? Who decided that the plumbing plan needs to be on blue paper and the electrical plan on yellow? Who decided that every single drawing must include a scale, a date, and the architect's signature? That's the framework. A framework isn't the blueprint itself. It's the rules for making the blueprints. It's the universal standard, the building code that everyone agrees to follow. It ensures that the plans drawn up by the team in California make perfect sense to the construction crew in Texas. It's the system that prevents chaos. Without a framework, every department in a company is speaking a different language. The marketing team describes a customer as a lead. The sales team calls them a prospect. The support team calls them a user. The finance team just sees them as an account number. They're all talking about the same person, but they have no common ground. The IT team then gets a request to build a customer management system, and they have to ask, which customer? Whose definition are we using? It's a complete mess. It's like trying to build a house where the plumber uses inches, the electrician uses centimeters, and the carpenter just eyeballs it. The house is guaranteed to fall down. An enterprise architecture framework provides that common language. It's a pre-built structure of best practices, a collection of wisdom from thousands of companies that have already tried, failed, and figured out what works. It gives you a starting point, a set of templates, and a defined process, so you're not just staring at a blank page wondering where to begin. Now, there are a lot of frameworks out there, but for a beginner, you really only need to know about the two heavyweights, the titans of the industry. Think of them as the Coke and Pepsi, the Ford and Chevy of the EA world. Their names are Zachman and TOGAF. Let's start with the grandfather of them all, the Zachman framework. Created by John Zachman at IBM back in the 80s, it's less of a how-to guide and more of a what's-what guide. The best way to think of the Zachman framework is as a giant empty filing cabinet, or maybe a periodic table for your business. It's a grid, a 6x6 matrix. The columns are interrogatives, simple questions. What? How? Where? Who? When? And why? The rows represent different perspectives, from the CEO's high-level view all the way down to the nitty-gritty details a programmer needs. So you can go to a specific box in this grid, say the what column in the business owner row, and that box is where you put the blueprint describing all the major business objects, things like product, customer, or order. Go down a level to the what column in the IT designer row, and you'll find the logical data model showing how those things relate to each other. The Zachman framework is brilliant because it forces you to consider every single aspect of your enterprise from every single viewpoint. It's a tool for thinking, for organizing. It doesn't tell you how to build the house, but it gives you a perfect, organized checklist to make sure you haven't forgotten to design the windows or the front door. It ensures completeness. Its main goal is to create a perfect, holistic description of the entire company, a true enterprise-wide blueprint. But what if you don't want to just describe your company? What if you want to change it? What if you want to move from your old crumbling headquarters into a brand new high-tech skyscraper? That's where the other heavyweight comes in, TOGAF. TOGAF stands for the Open Group Architecture Framework. If Zachman is the filing cabinet for organizing your blueprints, TOGAF is the step-by-step instruction manual for a major renovation project. It is all about process. It is a method. It doesn't just give you empty boxes to fill. It gives you a detailed, cyclical process to follow called the Architecture Development Method, or the ADM. Think of the ADM as a wheel that's always turning. Starts with a vision, where do we want to go? Then it moves to understanding your current architecture, where are we now? Then you define the target architecture, what will our new skyscraper look like? Then you identify the gaps. What's the difference between the old building and the new one? Then you plan the migration, you implement the projects, you govern the process, and you manage the changes. And once you're done, the wheel turns again. You start looking at the next improvement, the next renovation. It's a cycle of continuous improvement. So let's put it all together with a simple analogy. Imagine you want to cook a gourmet meal. The Zachman framework is like a complete encyclopedia of every ingredient in the world. It tells you what a tomato is, its chemical composition, where it grows, who grows it, and why it's used in cooking. It gives you the perfect classification for everything in your kitchen. TOGAF, on the other hand, is the recipe. It doesn't care as much about the chemical composition of a tomato. It tells you, Step 1, preheat the oven. Step 2, chop 3 tomatoes. Step 3, sauté with garlic. It's the action-oriented guide to get you from a pile of ingredients to a finished meal. This is the biggest source of confusion for beginners. They ask, should I use Zachman or TOGAF? But that's the wrong question. They're not competitors, they're complementary. You use the Zachman way of thinking to make sure you've identified and organized all your ingredients, your business processes, your data, your applications. And you use the TOGAF process to have a clear step-by-step recipe for combining those ingredients to achieve a specific business outcome. Zachman is the noun, TOGAF is the verb. Zachman is the map, TOGAF is the GPS giving you turn-by-turn directions. Now you might be thinking, this sounds incredibly complicated. Do we really need to do all this? And the honest answer is, it depends. If you're building a garden shed, you don't need a 300-page building code. You can just sketch it on a napkin and get to work. But if you're building a 100-story skyscraper, you absolutely need that code. You need that rigor. You need that shared understanding. These frameworks are the collected wisdom of decades of massive, complex projects. They exist because building and changing large organizations is brutally difficult, and going in without a plan, without a shared language, is a recipe for disaster. It leads to multi-million-dollar projects that fail, systems that don't talk to each other, and departments that are constantly at war. Using a framework is about reducing risk and increasing the chances of success. It's about learning from the mistakes of others instead of repeating them yourself. So now we understand the what, the blueprints and models that describe the business. And we understand the how, the frameworks and rules we use to create those blueprints in a consistent, organized way. We have the design and we have the building code. But that leaves one giant, unanswered question. Who actually does this work? Who is the person that walks into the boardroom and understands the CEO's vision, then walks down to the server room and understands the engineer's technical constraints? Who is the master planner that holds all these complex blueprints in their head? So you have the blueprints and the building code. But who is the master builder? Who is the person that stands between the CEO's dream and the engineer's reality, holding it all together? That person has a specific title, and their job is one of the most misunderstood, yet most critical roles in any modern company. That person is the enterprise architect. And if you think that sounds like a fancy title for a senior programmer or an IT manager, you're not alone. But you're also missing the entire point. That's like looking at the chief architect of New York City and saying, oh, so you're a really good bricklayer. The bricklayer builds the wall. The architect decides where the city goes. An enterprise architect or EA doesn't write code day to day. They don't typically manage the help desk. They operate at a completely different altitude. They are the strategic link between the boardroom's vision and the server room's reality. Their job is to create the master blueprint for the entire organization, not just for one piece of software, not just for one department, but for everything. Imagine a company as a massive, sprawling city. The CEO is the mayor who says, I want our city to be the world's leading center for commerce, with happy citizens, efficient transport, and beautiful parks. Great vision. But how do you actually do that? You don't just tell 1,000 different construction crews to start building. If you did, you'd get chaos. You'd have a skyscraper built on top of a water main, a residential area next to a toxic waste dump, and 10 different incompatible railway systems that don't connect. The city would grind to a halt. It would collapse. The enterprise architect is the city planner. They take the mayor's vision and they draw the map. They design the grid. They define the zones. This is the financial district, this is residential, this is industrial. They design the core infrastructure, the highways, the power grid, the water supply that everything else will depend on. They ensure that a building constructed today will still fit into the city's plan 10, 20 years from now. That is the essence of enterprise architecture. It's the practice of designing the entire business, its processes, its information systems, its technology, for alignment, for efficiency, and for future growth. So how do they actually do this? What does this master blueprint look like? It's not one single document. It's a holistic view broken down into 4 critical layers, or domains. Understanding these 4 domains is the key to understanding the entire field. First, you have business architecture. This is the why. Before you lay a single brick, you have to understand the purpose of the city. What is its economic strategy? What services must it provide to its citizens, the customers? Business architecture maps out the company's strategy, its governance, its organizational structure, and its key processes. It answers questions like, what do we actually do as a business? How do we make money? How do we deliver value to our customers? The EA works with business leaders to document this. This is the zoning map of our city. It says, this is our commercial zone. This is our government center. This is our innovation district. It ensures that whatever technology we build, it directly serves a core business purpose. No building for building's sake. Second, we have data architecture. If business architecture is the why, data architecture is the what. What is the lifeblood of our city? It's information. Data architecture is the city's water and sanitation system. It defines how data is stored, managed, and moved around the organization. Is our drinking water, our customer data, clean, safe, and easily accessible? Or is it polluted and stuck in leaky, isolated pipes? The EA designs the master plan for the company's data. This means creating a single source of truth, so the sales department and the marketing department aren't working from two different, conflicting sets of customer information. It's about ensuring data is an asset that flows freely to where it's needed, not a liability locked away in 1,000 different basements. Third, there's application architecture. This is the how, or at least the first part of it. These are the actual buildings and services in our city. The applications are the software systems that the business uses to perform its functions. The bank, the post office, the factory, the hospital, each is an application. The EA's job isn't to design every single building, but to determine what kinds of buildings we need and how they should interact. Do we need a massive centralized skyscraper for our core financial system? Or a series of smaller interconnected buildings for our regional sales offices? Application architecture ensures these systems don't exist in isolation. It creates a blueprint for how they talk to each other, preventing the creation of a software shantytown, where every department builds its own little shack without considering the wider city. This is where you avoid having 5 different payroll systems that can't communicate, forcing employees to manually re-enter the same information over and over again. Finally, we have the fourth layer, technology architecture. This is the foundational how. This is the stuff everything else is built on. It's the physical ground, the bedrock, the roads, the power grid, and the communication lines of our city. This layer describes the software and hardware infrastructure needed to support the applications above it. This includes the servers, the networks, the cloud platforms, the operating systems, and the databases. The EA makes crucial decisions here. Are we building our city on solid granite or on a swamp? Are we using modern high-speed fiber optic cables or old crumbling copper wires? These choices determine the performance, security, and scalability of the entire enterprise. Choosing the right technology architecture is the difference between a city that can grow into a thriving metropolis and one that's stuck with crumbling infrastructure, unable to expand. So, you have these 4 layers: business, data, application, and technology. The magic of the enterprise architect is that they see how all 4 connect. They understand that a change in business strategy, business architecture, might require a new way to handle customer information, data architecture, which necessitates a new CRM application architecture, which in turn needs to run on a scalable cloud platform, technology architecture. They see the entire chain of cause and effect. Without this role, companies grow organically, which sounds nice, but in reality it means they grow like a weed, chaotically and without structure. Let me tell you a quick, true story. A major retail company was growing fast. Each department was given a budget to solve its own problems. The marketing team bought a state-of-the-art marketing platform. The sales team bought a separate best-in-class sales platform. The logistics team built their own custom inventory system. On the surface, everyone was innovating, but under the hood, the city was collapsing. The marketing platform had its own customer list. The sales platform had another customer list. The inventory system had no idea what either of them was doing. To get a single view of a customer, what they were being marketed, what they bought, and whether the product was in stock required 3 people in a room manually pulling reports and comparing spreadsheets. It was slow, it was expensive, and it was riddled with errors. They had built 3 beautiful, isolated mansions, but they had forgotten to build the roads between them. When a competitor with a unified system entered the market, offering a seamless online experience, this retail giant couldn't react. They were too tangled in their own self-made complexity. Their lack of architecture was a fatal flaw. The enterprise architect is the force that prevents this chaos. They are the guardians of the big picture. They use established frameworks. Think of them as a universal set of symbols for city planning, like TOGAF or the Zachman framework, to create and communicate their blueprints, ensuring everyone from the CEO to the junior developer is reading from the same map. They don't just build for today. They build the foundation for the future. They ask the hard questions. Will this decision help us in 5 years? Or will it just create another isolated silo we have to deal with later? They are the ultimate systems thinker, balancing the long-term strategic goals of the business with the short-term, practical realities of technology. It's an incredibly challenging role, requiring a rare mix of technical depth, business acumen, and communication skills. Now you understand who the architect is and the 4 layers of the blueprint they create. But this raises the most important question of all. Where do you even begin? You can't just walk into a massive, complex company and start drawing a new map from scratch. How does an enterprise architect take the very first step in understanding the chaotic city that already exists, before they can even dream of building a better one? They start by becoming an archaeologist, a detective, and a cartographer all at once. They don't arrive with a bulldozer. They arrive with a magnifying glass and a notebook. The first, most critical mission is not to change anything but to understand everything. This process has a name: creating the as-is architecture, or the current state blueprint. It's the act of drawing a painfully honest map of the city exactly as it is today, not as the CEO thinks it is, not as the marketing brochures claim it is, but as it truly functions, warts and all. Imagine trying to fix a city's traffic problem. You wouldn't just start building a new highway, right? You'd first spend weeks, maybe months, just observing. You'd count the cars, study the traffic light patterns, identify the rush hours. You'd map the one-way streets that make no sense, the intersections that are always gridlocked, and the shortcuts that only the locals know. The enterprise architect does the exact same thing, but for the flow of information and processes within a company. They are creating the master map of the existing chaos. So how do they gather this intelligence? It's not like there's a single perfect map of the company tucked away in a filing cabinet. If that existed, they probably wouldn't need an enterprise architect. Instead, they have to piece it together from fragmented clues, and this detective work happens in 3 main ways. First, and most importantly, they talk to people. They conduct interviews with everyone from the executives in the corner offices to the data entry clerks in the cubicles. They don't ask, "Can you describe your part of the enterprise architecture?" That would be met with blank stares. Instead, they ask simple, powerful questions. Walk me through your day. What's the most frustrating part of your job? If you had a magic wand, what one system would you fix? Where do you get the information you need? And where do you send it when you're done? They are listening for the stories. The story of the sales team that has to manually copy and paste customer information into 3 different systems, creating a huge risk of error. The story of the finance department that waits 2 weeks for a critical report because the data is locked away in an ancient, unsupported piece of software. These stories are the human element of the architecture. They are the traffic jams, the potholes, and the crumbling bridges of the corporate city. An architect who ignores these stories is just drawing lines on a map. An architect who listens understands the soul of the city. Second, they become document archaeologists. They dig through the digital archives, unearthing project plans from 5 years ago, system manuals for software nobody has updated in a decade, and network diagrams that were obsolete the moment they were printed. It's a messy, painstaking process. They are looking for the city's hidden history. Why was this bizarre, inefficient process put in place 10 years ago? The documents might reveal that it was a temporary workaround for a server that has since been decommissioned, but the workaround, like a forgotten piece of scaffolding, was never removed and is now a permanent, creaking part of the structure. They are finding the why behind the what. Third, they use technology to map technology. They can't just rely on what people say or what old documents claim. They need ground truth. Architects and their teams use automated discovery tools that scan the company's network like a satellite, taking high-resolution photos. These tools identify every server, every database, every application running in the organization. They map the connections, the data flows, the software versions. This is the equivalent of using ground-penetrating radar to find every single water pipe, electrical conduit, and sewer line beneath the city streets. It reveals the hidden infrastructure that no one person fully understands, showing dependencies that are often surprising, even to the IT teams that manage them. Now, as all this information, the interviews, the documents, the scans starts pouring in, the architect needs a way to organize it. They can't just dump it all into one giant unreadable map. So they organize their findings into 4 distinct, but interconnected layers or perspectives. Think of them as 4 different map overlays for our city. The first layer is the business architecture map. This overlay doesn't show technology at all. It shows what the company does. It maps the primary functions. How does the company sell products? How does it handle customer service? How does it manage its finances? It identifies the key processes, the value streams, and the strategic goals. This is the map of the city's districts and economic activity. Here's the financial district. Here's the manufacturing hub. Here's the retail corridor. It answers the fundamental question: why does this city even exist? The second layer is the data architecture map. This shows how information, the lifeblood of the company, flows through the city. Where is customer data stored? Is it in one secure, clean reservoir? Or is it scattered in 100 leaky buckets all over town? How does an order placed on the website, the retail district, get to the warehouse, the manufacturing hub? This map shows the information pipelines. It reveals where data is duplicated, where it gets corrupted, and where it becomes a bottleneck, like a clogged water main preventing an entire district from functioning properly. The third layer is the application architecture map. This overlay shows the actual software systems that people use to do their jobs. These are the buildings of our city. The big, powerful ERP system might be a central skyscraper. The team's collection of spreadsheets could be a sprawling, unregulated shantytown. The customer relationship management software is the city's bustling marketplace. This map shows which applications support which business functions, how they connect to each other, and crucially, which ones are modern, efficient structures and which ones are crumbling ruins that are expensive to maintain and dangerous to inhabit. Finally, the fourth layer is the technology architecture map. This is the foundational infrastructure. The servers, the networks, the cloud platforms, the laptops. This is the map of the city's physical roads, its power grid, its communication towers, and its foundations. Is the city built on modern, stable bedrock? Or is it built on a swamp with an outdated, unreliable power supply that flickers every time there's a storm? This map shows the real physical and digital nuts and bolts that everything else depends on. And here is where the magic happens. The enterprise architect takes these 4 maps, business, data, application, and technology, and layers them on top of each other. For the first time, a complete holistic picture of the entire organization emerges from the fog. Suddenly, the connections become clear. They can see that a critical business process like fulfill customer order relies on a specific piece of data, customer address, which is passed between 3 different applications, 2 of which are running on a single 20-year-old server that has no backup. This is the aha moment. It's the moment the detective lays all the evidence on the table, and the pattern becomes undeniable. The constant customer complaints aren't a training issue. They're caused by data corruption between 2 ancient applications. The reason the finance team can't close the books on time isn't because they're slow. It's because their software runs on an overloaded server that it shares with the marketing department's video rendering system. The as-is blueprint isn't just a drawing. It's a diagnosis. It's the MRI that reveals the hidden sicknesses of the organization. It's a powerful and often shocking tool for showing leadership the true state of their company, stripped of all wishful thinking. It provides the undeniable evidence needed to justify change. But this detailed and sometimes terrifying map of the present is only the first half of the equation. It tells you exactly where you are, but it doesn't tell you where you need to go. Now that the enterprise architect has a perfect high-resolution picture of the messy, inefficient, and crumbling city of today, how do they design the gleaming, efficient, and resilient city of tomorrow? And more importantly, how do they create a realistic plan to get there without bulldozing the entire city and starting from scratch? The answer lies not in a single cataclysmic event, but in a brilliant, carefully orchestrated series of moves. It's the difference between demolition and renovation. You don't level the city. You create a master plan, a roadmap that guides its evolution block by block, system by system, from what it is today into what it needs to be tomorrow. This is the heart of implementing enterprise architecture. It's where the blueprints meet the bulldozers, and the vision becomes a reality. This master plan is called an enterprise architecture roadmap, and it is, without a doubt, one of the most powerful tools in the entire field. It's a strategic timeline that lays out the sequence of changes needed to get from your current state to your target state. But it's so much more than just a project plan with dates on it. A true roadmap links every single initiative, every project, every technology upgrade, directly back to a specific business goal. It answers not just what and when, but more importantly, why. To understand this, let's go back to our city. The roadmap wouldn't just say, build a new bridge by 2026. It would say, in Q1 2025, we will begin reinforcing the foundations on the north side of the river. Why? To support the new bridge. In Q3 2025, we will begin construction of the bridge itself. Why? To reduce crosstown traffic by 30%, which is a key objective in our city's economic growth plan. This will enable the commercial development plan for 2027. Every step is a logical progression, and every step has a purpose. In between the city of today, our as-is architecture, and the city of tomorrow, our to-be architecture, are a series of what we call transition architectures. Think of these as snapshots or models of the city at various points in the future. They are the deliberate, planned intermediate states. A transition architecture is what the city will look like after we've completed the first phase of projects. Maybe in this version the old bridge is still there, but the new high-speed rail line is operational. It's not the final vision, but it's a massive improvement and a crucial stepping stone. The roadmap, then, is the story of how we move from one transition architecture to the next, and the next until we finally arrive at our destination. So, the billion-dollar question is, how do you decide what to do first? You have 100 problems to solve and a limited budget. Do you fix the sewers, build a new school, or upgrade the power grid? This is the art and science of sequencing. Enterprise architects use several key principles to make these critical decisions. First is business value. You identify the projects that will deliver the biggest, most immediate impact on the organization's most pressing problems. If our city's biggest problem is daily gridlock that's crippling commerce, then the projects focused on improving traffic flow are going to get top priority. In a company, if the biggest problem is a 48-hour delay in processing customer orders, then the project to automate that specific workflow is going to be front and center on the roadmap. It's about tackling the biggest pain points first. Second, you have to manage dependencies. This is absolutely critical. You can't build a new skyscraper on a weak foundation. You can't build a new state-of-the-art hospital if you don't have the electrical grid to power it or the roads to access it. In the corporate world, this means you can't launch a fancy new data analytics platform if your underlying data is a complete mess, stored in 50 different incompatible spreadsheets. The roadmap forces you to think like a real builder. You must sequence the work logically. First, you run the new power lines. Then, you build the hospital. First, you clean up and centralize your data. Then, you build the analytics platform on top of it. One enables the other. Third is a concept you could call quick wins versus foundational work. Some projects are like building a new sewer system. They are incredibly important, absolutely essential for the long-term health of the city, but they're also expensive, disruptive, and nobody throws a parade when you're done. This is foundational work. Other projects are like opening a beautiful new public park. They are highly visible, popular, and generate immediate goodwill and excitement. These are quick wins. A great roadmap balances both. You have to do the hard foundational work, but you also need to sprinkle in those quick wins to show progress, build momentum, and keep everyone, from the executives signing the checks to the employees doing the work, energized and bought into the vision. Let's translate this directly to a real-world business scenario. Imagine an old, successful manufacturing company we'll call Legacy Parts Incorporated. Their as-is architecture is a mess. The sales team uses an ancient system from the 90s. The inventory team uses a custom-built spreadsheet that only one guy named Dave knows how to use. The finance department uses a completely different accounting package. Nothing talks to anything else. When a big order comes in, it's a flurry of phone calls, emails, and manual data entry to see if they have the parts, can build the product, and can ship it on time. It's slow, it's expensive, and it's full of errors. The to-be vision is a sleek, integrated system. A single platform where a sales order automatically checks inventory, schedules production on the factory floor, and alerts the finance department, all in real time. It's a beautiful vision, but they can't get there overnight. So the enterprise architect lays out a roadmap. Phase 1 is the foundational work, the unglamorous sewer system. They will spend the first 6 months implementing a new, modern, centralized database. The goal is to create a single source of truth for all product, inventory, and customer information. No one outside the IT department will even see this change, but it's the most important step in the entire plan. This is transition architecture number 1. Phase 2 leverages that new foundation for a quick win. In the next quarter, they roll out a brand new, cloud-based CRM system for the sales team. Because the central database is already in place, the new CRM can instantly pull real-time inventory and production data. For the first time ever, a salesperson can tell a customer exactly when their order will ship, right on the first phone call. The sales team is ecstatic. This visible success builds huge momentum for the entire transformation. Phase 3 builds on that momentum. They now replace Dave's spreadsheet with a proper inventory management module that plugs directly into the central database and the new CRM. Now, as sales are made, inventory is depleted in real time, and the system can even automatically order new raw materials when stock runs low. This is transition architecture number 2. More efficiency, fewer errors. You see the pattern? Each phase is a self-contained project that delivers its own value, but it also serves as a critical foundation for the next phase. The roadmap turns a terrifying monolithic project called digital transformation into a manageable, logical series of achievable steps. But there's one more piece to this puzzle. As you execute this grand plan, how do you make sure everyone sticks to it? What stops the marketing department from going out and buying some shiny new software that doesn't connect to the new central database, creating a brand new problem, a new data silo, right in the middle of your beautiful new city? This is the role of enterprise architecture governance. Think of it as the City Planning Commission. Their job isn't to design the buildings, but to ensure that anyone who wants to build something follows the master plan. They review the blueprints for every new project, every new software purchase, every new technology initiative, and they ask the hard questions. Does this align with our target architecture? Does it use our standard technologies? Does it support our strategic business goals? Governance is the mechanism that keeps the entire organization aligned. It ensures that the roadmap isn't just a pretty document that sits on a shelf, but a living guide that actively shapes every technology decision the company makes. It's the discipline that prevents you from slowly, unintentionally, rebuilding the same crumbling city you just worked so hard to escape. It ensures that every single brick that is laid, every dollar that is spent, is contributing to the construction of that gleaming, efficient, and resilient city of tomorrow. So how do we get there? How do we ensure this grand vision of a gleaming metropolis doesn't just end up as a glossy brochure, a set of beautiful architectural drawings that gathers dust in a forgotten corner of the CEO's office? Because vision without execution is just hallucination. This is where enterprise architects roll up their sleeves and become less like dreamers and more like master city planners, armed with blueprints, zoning laws, and a very, very detailed construction schedule. They use what are called enterprise architecture frameworks. Now, don't let the word framework scare you. It sounds complicated and academic, but I want you to think of it simply as the city's official rulebook. It's the collection of zoning laws, building codes, safety regulations, and public policies that everyone has to follow. It's the master plan that ensures you don't have a chemical plant built next to an elementary school, or a skyscraper constructed on a foundation meant for a 2-bedroom house. These frameworks, and you might hear names thrown around like TOGAF or Zachman or SAFE, they all serve the same fundamental purpose: to provide a structured, repeatable method for designing and building our digital city. They give us a common language and a set of tools so that everyone, from the software developers laying the digital bricks to the executives approving the budget, is working from the same set of blueprints. It's what stops one department from building a 6-lane superhighway that leads directly into another department's quiet residential cul-de-sac. It brings order to the potential chaos of creation. And a core part of this rulebook is that it forces us to look at our city not as one giant, jumbled mess, but as a series of interconnected layers or districts. In the world of enterprise architecture, there are typically 4 of these fundamental districts that we must understand and design. First, you have the business architecture. This is the why. This is the City Council and the Economic Development Board all rolled into one. It defines the very purpose of our city. What kind of city are we building? Are we a financial capital? A manufacturing hub? A center for innovation and technology? The business architecture maps out the company's strategy, its goals, its core processes, and how it creates value. It answers the question, what do we actually do here, and how can we do it better? Without a clear business architecture, you're just building roads and skyscrapers with no idea who will use them or why. Second, nestled right underneath is the data architecture. If business architecture is the why, data architecture is the what. Think of it as the city's essential utilities: the water supply, the power grid, the communication lines. Data is the lifeblood of the modern enterprise. It's the electricity that powers every decision, the water that nourishes every process. The data architecture is concerned with how this vital resource is managed. Where does our data live? How does it flow from the power plant to the homes and factories? Is it clean, reliable, and secure? Is our drinking water pure? Or is it polluted? A city with a faulty power grid and contaminated water is a city on the verge of collapse, no matter how beautiful its buildings are. Which brings us to the third layer, the application architecture. This is the how. These are the actual buildings and structures of our city. The skyscrapers, the factories, the hospitals, the homes. In business terms, these are the software applications, the CRM, the ERP, the custom-built programs, the mobile apps that employees and customers use to get work done. The application architecture maps out all of these systems and, crucially, how they interact with each other. Are our buildings modern, efficient, and interconnected with sky bridges? Or are they isolated, crumbling tenements with leaky roofs and faulty wiring? Are we building a cohesive, functional skyline, or a chaotic jumble of incompatible structures? Finally, we have the foundation of it all, the technology architecture. This is the where. This is the very ground our city is built upon. It's the bedrock, the sewer systems, the physical roads, the bridges, and the tunnels. In the corporate world, this is the hardware, the servers, the cloud infrastructure, the networks, and the operating systems. It is the fundamental platform that supports everything else. You can design the most magnificent skyscraper in the world, the most powerful application, but if you try to build it on a swampy foundation, it's going to sink. The technology architecture ensures the ground is stable, the infrastructure is robust, and it can support the ambitions of the city being built on top of it. Now, the real magic of enterprise architecture is understanding that these four districts, business, data, application, and technology, are not independent. They are a deeply interconnected stack. A change in one has a ripple effect through all the others. Let's say the city council, the business architecture, decides they want to attract a new high-tech industry to the city. That's a great strategy, but it immediately raises questions for the other layers. Does our power grid, our data architecture, have the capacity to support these new high-tech factories? Are our buildings, our application architecture modern enough to house these innovative companies, or do we need to construct new ones? And is the ground itself, our technology architecture, stable and scalable enough to handle this new development? An enterprise architect lives in the connections between these layers. They ensure that the business strategy of building a tech hub is supported by a plan to upgrade the data, application, and technology infrastructure. Without that holistic view, the strategy is just a pipe dream. So, with our rulebook, our framework, and our understanding of the four districts, we can now create the master construction plan. This is called the EA roadmap. And this is critical. You don't rebuild a city by bulldozing everything overnight. That would be chaos. You do it in careful, planned phases. The roadmap is the timeline that takes us from our current, crumbling city to our future, gleaming metropolis. It's the transition plan. It might say, in Q1, we're not going to build any new skyscrapers. Instead, we're going to focus on reinforcing the foundation. We're going to upgrade our technology architecture by moving our servers to the cloud. Then in Q2, we'll focus on the utilities. We're going to clean up our data architecture by creating a single, reliable source for customer information. Then in Q3, with a stronger foundation and cleaner utilities, we can finally start demolishing that old, inefficient tenement building and begin construction on a new state-of-the-art office tower, our new CRM application. This phased approach, this roadmap, is what makes digital transformation manageable. It breaks down a massive, overwhelming vision into a series of logical, achievable projects. Each step is a deliberate move away from the old city and a concrete step toward the new one, ensuring that every dollar spent and every hour worked is pushing in the same strategic direction. So we have the blueprints, the zoning laws, and the construction schedule. We understand the districts of our city and the foundations they're built on. It seems like we have everything we need to start building, right? But a city isn't just buildings and roads. It's people. And getting all those people, the council members, the business owners, the construction workers, the residents, to all agree on the plan, to fund it, and to follow it, that is where the real challenge begins. This is the fundamental shift in thinking that separates a good architect from a great one. The blueprint is the easy part. The real work is in the diplomacy, the negotiation, the salesmanship. This entire process, this system of decision-making and oversight, has a name: enterprise architecture governance. Now I know what you're thinking. The word governance sounds heavy. It conjures images of stuffy boardrooms, endless paperwork, and a big red No stamp. And let's be honest, when done poorly, it can be exactly that. But when done right, governance isn't a brake pedal. It's a steering wheel. It doesn't stop you from moving forward. It ensures everyone in the car is headed to the same destination, safely and efficiently. Let's go back to our city. What happens if there's no governance? No zoning board, no building codes, no city council approval process? You get chaos. One person decides to build a chemical factory right next to an elementary school. Another builds a 50-story skyscraper that blocks out the sun for an entire neighborhood. A third paves a private road right through a public park. Each person might be optimizing for their own needs, but the city as a whole becomes unlivable, inefficient, and dangerous. The exact same thing happens in a company. Without governance, the marketing department buys a new software tool that can't share data with the sales team's CRM. The finance team in Europe implements a different accounting system than the team in North America, making a global financial report a nightmare to compile. A development team, excited about a new technology, builds a critical application on a platform that no one else in the company knows how to support. Each team solved their immediate problem, but they created a massive long-term problem for the entire enterprise. This is called creating silos, and it's the digital equivalent of building walls all over our city. So, how does EA governance prevent this? It establishes the rules of the road. It's a framework for making decisions. Typically, it has a few key components. First, you have an Architecture Review Board, or ARB. Think of this as the city's planning commission. It's a group of senior leaders from both the business and technology sides of the company. When a team wants to start a major new project, build a new skyscraper if you will, they bring the plans to the ARB. The ARB doesn't just look at the project in isolation. They ask the tough questions. How does this align with our overall business strategy? Does it use our standard approved technologies? How will it connect with our existing systems? Does it introduce any security risks? Will it be reliable and scalable? The goal of the ARB isn't to say no. It's to say, how can we do this the right way? It's to ensure that every new building contributes to the health and future of the entire city, not just the single lot it's built on. Second, governance defines standards and policies. These are the building codes. A standard might be something like, all new applications must use the company's single sign-on service to ensure a secure and seamless user experience. A policy might be, no sensitive customer data is allowed to be stored on laptops. These aren't arbitrary rules meant to make life difficult. They are guardrails established to protect the company, reduce complexity, and ensure quality. Just like you wouldn't want a plumber using lead pipes in your house in 2024, you don't want a developer using an outdated, insecure programming language for your new online banking app. And third, there's compliance. This is the building inspector. It's the process of checking to make sure that projects are actually following the standards in the approved designs. It's about accountability, because a blueprint that everyone ignores is just a very expensive piece of paper. But here's the most critical part, and it's what so many organizations get wrong. Governance cannot be just a hammer. You can't just dictate rules from an ivory tower and expect people to be happy about it. That's where the human element, stakeholder management and communication, comes in. This is the art of enterprise architecture. An enterprise architect is part engineer, part city planner, and part diplomat. They have to understand the motivations and concerns of every single stakeholder. The chief financial officer, for example, is primarily concerned with return on investment and managing costs. You can't talk to her about the elegance of a microservices architecture. You have to talk to her about how that architecture will reduce long-term maintenance costs by 30% and allow the company to enter new markets faster. The head of sales doesn't care about data normalization. He cares about his team having fast, reliable access to customer information so they can close deals. So the architect's job is to show him how a new centralized customer data platform, the new central library in our city, will give his team a 360-degree view of every customer, leading to a 15% increase in cross-selling opportunities. You have to speak their language. You have to translate the technical blueprint into tangible business value. This is a constant process of communication and education. It's about creating a shared vision that everyone can buy into. You have to be a storyteller. You're not just presenting a diagram. You're painting a picture of a better future. You hold town hall meetings. You do roadshows for different departments. You show them the map of the current city, with all its traffic jams, crumbling infrastructure, and disconnected neighborhoods. You acknowledge their pain points. You say, we know this is a problem. Then you show them the blueprint for the future city. You show them the high-speed data highways that will replace the congested dirt roads. You show them the beautiful interconnected public services that will replace the isolated, inefficient silos. You explain why you're building a bridge here, or zoning a new business park there. You make them part of the process. You get their feedback. You make them feel like they are co-creators of this future city, not just subjects of a top-down decree. When people understand the why behind the rules, they are infinitely more likely to follow them. They stop seeing the architecture review board as a roadblock and start seeing it as a partner, a group of experts helping them build something better and more durable. They stop seeing standards as restrictive and start seeing them as helpful shortcuts that save them time and prevent them from reinventing the wheel. Ultimately, effective governance isn't about control, it's about enablement. It's about creating an environment where teams have the freedom to innovate, but within a framework that ensures their innovations contribute to the greater good. It's a delicate balance. Too little governance and you have chaos. Too much and you stifle creativity and speed. The sweet spot is where the architecture provides a solid foundation and a clear direction, empowering people to build amazing things on top of it. Getting this right, managing the politics, communicating the vision, and building consensus, is arguably the most difficult and most valuable part of being an enterprise architect. You can have the most brilliant technical blueprint in the world, but if you can't get the people to believe in it, to fund it, and to follow it, it will never leave the drawing board. So we have the blueprints. We have the building codes and the planning commission in place. We've held the town halls and gotten the citizens on board. The city is finally being built, piece by piece, according to the master plan. But cities don't stand still. Technology, culture, and the economy are always changing. A plan that was brilliant yesterday might be obsolete tomorrow. So how does the city plan for the future? As technology accelerates at a dizzying pace, how does the role of the city planner, the enterprise architect, evolve to keep up? What new challenges and what incredible new opportunities lie just over the horizon? The city of the future doesn't just have taller skyscrapers or faster monorails. It breathes, it learns, it adapts. Imagine our city planner, the enterprise architect, standing on a high vista, looking not at a static map, but at a living, pulsing organism. The roads are no longer just asphalt. They are intelligent data streams, constantly rerouting traffic to avoid congestion, powered by artificial intelligence. This is the first major shift. AI and machine learning are becoming the central nervous system of the enterprise. The architect is no longer just planning where the roads go. They're designing the city's intelligence, ensuring it learns from its citizens' behavior, the customer's actions, to provide better services, predict future needs, and even heal itself when something breaks. The very ground the city is built on is also changing. In the past, our planner had to lay a massive permanent concrete foundation for every single district. This was slow, expensive, and inflexible. Today, and increasingly in the future, the foundation is like a smart cloud. This is the world of cloud-native and serverless architecture. Instead of a fixed foundation, imagine being able to summon exactly the infrastructure you need, precisely when you need it, and have it vanish the moment you don't. Need a pop-up market for a day? The infrastructure appears. Need a stadium for a major event? The capacity scales up instantly. The architect's job is to design systems that are fluid and elastic, not rigid and brittle. They're planning for a city that can expand, shrink, and reconfigure itself in real time, based on demand, saving immense resources and enabling incredible agility. And what flows through this city? What is its most vital resource? Not water, not electricity. It's data. For decades, data was treated like a central reservoir, controlled by a single water authority. It was slow, bureaucratic, and often, the water that reached the outer districts was stale. The future is a concept called the data mesh. Instead of one central reservoir, imagine every district, every business unit, like sales, marketing, operations, being responsible for its own clean, fresh, and readily available water supply. They own it, they ensure its quality, and they provide easy-to-use taps for anyone else in the city to access it. The enterprise architect's role transforms from being the gatekeeper of the central reservoir to designing the citywide plumbing standards, ensuring every tap is compatible and that the water is trustworthy, no matter where it comes from. This decentralizes power and makes the entire city more resilient and innovative. This leads to one of the most powerful ideas for the future, the composable enterprise. Think about how we build skyscrapers today. We don't fire bricks one by one in a kiln on site. We use prefabricated, high-quality, standardized components that are assembled quickly and efficiently. The future of business is the same. Instead of building every single business capability from scratch, the architect designs a system where the business can pick and choose from a catalog of business Legos. Pre-built digital services for things like payment processing, customer identification, or shipping logistics. They can then snap these pieces together to create new products and services at lightning speed. Want to launch a new subscription service? Just combine the customer login component, the payment component, and the content delivery component. The architect becomes the master designer of the Lego set itself, ensuring all the pieces fit together perfectly, empowering the entire organization to build, innovate, and adapt without waiting for a massive, multi-year construction project. But this gleaming, intelligent, adaptable city of the future faces new kinds of threats. The old moats and walls are useless. The new threats are invisible. Cybersecurity is no longer just about putting a lock on the front door. It's about securing millions of interconnected devices, intelligent systems, and flowing data streams from digital sieges that are more sophisticated than ever. The architect must be a master strategist in this new world, designing a defense in depth, a city with an immune system, not just a wall. And there's a new social contract to consider. With AI making decisions, who is responsible when it makes a mistake? As we collect more and more data on our citizens, how do we protect their privacy and earn their trust? The architect of the future must also be an ethicist, building frameworks that ensure fairness, transparency, and accountability are baked into the city's digital DNA. They must ask not only can we build this, but should we build this? This is the crucial evolution. The enterprise architect of tomorrow is less of a technical draftsperson and more of a strategic diplomat. They spend less time in the server room and more time in the boardroom. Their most valuable tools are not software diagrams, but storytelling, influence, and empathy. They must be able to paint a vivid picture of the future city for everyone, from the CEO to the frontline engineer, and inspire them to help build it. They are the translators, bridging the deep chasm between the language of business strategy and the language of technological possibility. They are the guides, helping the organization navigate the fog of technological change, pointing out the opportunities while steering them away from the cliffs. So, after this entire journey, from understanding the 4 core domains to peering over the horizon at the future, what is the one single idea you should walk away with? It's this: enterprise architecture is not about controlling everything. It's about creating clarity. It's about making the invisible visible. It's about helping a complex organization see itself, understand how all its moving parts connect, and make smarter, more intentional decisions about its future. We started this journey by comparing it to city planning, and it's time to bring that metaphor home. Whether you are a CEO, a software developer, a marketing manager, or just starting your career, you live and work inside one of these cities. You might not have the title of enterprise architect, but you now possess the mindset. You can now see the hidden infrastructure, the business processes, the data flows, and the technological foundations that underpin everything you do. You can start asking the right questions. Is this new project building a beautiful mansion on a crumbling foundation? Are we creating another data silo? Or are we contributing to a shared, clean water supply? Are we building a rigid structure? Or are we using flexible, composable building blocks? This mindset, the ability to zoom out, see the entire system, and understand the connections, is a superpower. It allows you to move beyond simply doing your assigned task and start shaping the strategy. It's the difference between being a bricklayer and being an architect who understands how that single brick contributes to the grand cathedral. Enterprise architecture is the art and science of building better futures. It's about ensuring the digital world we are so rapidly constructing is not a chaotic, sprawling, and inefficient slum, but a smart, resilient, and humane city. It's about turning complexity into clarity and vision into reality. And now you understand the blueprint. You have the foundational knowledge to not just be a resident of the city, but to be one of its planners, its builders, and its future leaders. Go and build wisely.